So we work mostly in cross-laminated timber, handily. I have a piece here. Can I pass it around? Is that okay? We do like to pass the parcel, so everybody knows what's going on. It's okay, so look, there you go. So cross-laminated timber, this is genius material. And what it is, it's the part of the tree from the outside of the trunk. So the stuff that gets made into paper or chipped for fuel, the low-quality timber. And it's made into planks. The planks are all finger-jointed together, and they're laid out, they're sprayed with an adhesive, which is a water-based adhesive, it's a PU adhesive, not that much different from Pritt stick, right? And you spray that on, and then you lay another layer on top of planks perpendicular to the layer below, and then you put them in a big press, and you press them down, and they form these massive panels. So these panels come out of the factory like this. And you can see here, this is the window cut out, the roof profile, door here. So these panels, prefabricated in the factory, put on the back of a truck, brought to site, and craned into position, and screwed down with a cordless screwdriver. And there you have your building. So we looked like this in 2003. We were designing mostly nightclubs. That's me there, wearing a suit, trying to look important. And we built this little building, 45 square meters in CLT, first one in the UK. And what we drew in our CAD program, in our really rudimentary 2D CAD program, was exactly what arrived on site. In 6 hours, 4 people built this 3-story building with cordless screwdrivers. They dropped the panels in, screwed them together, and we had this beautiful little building. It's a nightclub for classical musicians. I've never been. And then we built a few houses after that, a few roof extensions in CLT. But always at the back of my mind, or at the forefront of my mind, was this notion that for architects, for contemporary architecture, the challenge is urban housing, high-density urban housing. You know, the whole planet is becoming increasingly urban. And actually, to solve the problem of that housing crisis, of that international housing crisis, to look at how we can build high-quality urban housing which responds to an understanding about climate change and about low energy, really is that's the kind of key sort of political design question of architects of our time. Not funny shapes. So we had this notion of high-density urban housing made of engineered timber. And for years, we'd get a job into the office, we'd design the building, and I'd sit down with the client, and we'd have what we began to call the timber chat, where we'd sit down with the client and we'd say, and we can build it in timber. And the client would say, no, you won't. You'll build it in concrete like everybody else, or I'll fire you. So we honed our idea around this, we honed the kind of arguments around this process, and we were able to demonstrate by 2008 that we could build this building more quickly, more cost efficiently than we would be able to build it in concrete. That we could demonstrate to our clients significant savings. And we also worked with the local government to say, look, this is a massive amount of carbon saving by doing this building in timber. And so in 2008, we built this building, completely honeycomb structure. So every wall, every floor, the stair core, the lift core, everything really tightly screwed together so that everything in the building is working. And we're able to rotate the plans as we went up the building. So on 8 stories of residential, we have 5 different sets of plans going up the building. And this building was 9 stories. Nothing really been done above 3 stories before, so it was quite a challenge. To get that through building code and all those sorts of things, as I'm sure you can imagine. So 29 apartments. And you can see here how the building's going together. So these are 75mm angle brackets, galvanized steel angle brackets with 100mm screws. And the whole building goes together just using that. And then you can see that in the ceiling here, that's where all the electric and the plumbing pipes go. And they're on these little plastic tags. So we've got these guys running around the site with stilts on, cordless screwdrivers just drilling into the ceiling. And one of the guys on site said to me, an electrician, explained to me that actually when you're an electrician and you apprentice as an electrician, the first thing you do is you hammer drill on site. You hammer drill into concrete, into the concrete ceiling to put the surfaces in. And then after about 18 months, your shoulder joint disintegrates. And when your shoulder joint is disintegrated, then they teach you about electrics. And the kind of environment that we have on our construction sites is something that I'm also going to talk to you about today. Because what we began to understand was that when you build with a new building material, lots of things are changed. Lots of things are affected by that. So this is a section, simple section. You can see that so floor panel going through, so 146 mil, floor panel, wall panel sits on that. So it's what they call a platform construction. So the floor, the wall, the floor, and you build up very simply. And in order to build this building from this new material, from this kind of, in order to prove that, our kind of mantra in the office became that we were setting out to prove that timber was a viable alternative for concrete and steel. Do you know the other thing we did as well? We got a picture out of a book of the pagoda in Kyoto, and we put a photocopy of it on the fridge. And at the same scale, we put a photograph. We put an image of our building to demonstrate that 700 years ago they'd built a building 3 times the height in timber, just so that we didn't get too worried about it. So what we did is we then put a resin-based screed on top of the floor slab, and we brought that up in hoses up the lift shaft, sprayed it on a Friday afternoon, and by Monday morning it was dry. And inside that we put underfloor heating, and that gave us a thermal and an acoustic mass on top of the slab. And then on the outside of the building, simple insulation and a rain screen cladding. So really simple kind of process, really simple building technologies. And you can see no tower crane, and also you see how close all the other buildings are here. Usually with a site like this, you'd have hundreds upon hundreds of cement mixers rolling in, maybe about, about a dozen a day, say, cement mixers pumping into the site. You'd have jackhammers, grinders, all that kind of thing going on site. But this whole building, as I was saying, went together with a cordless screwdriver and 2 deliveries of timber a day. And we built this building in 27 days, the entire structure, which was prefabricated. Everything arrived on site, plus or minus 2 millimeters. Everything that arrived on site was exactly what we had drawn in our office. So we finished the building in 11 months, from start to finish in 11 months. So there's no waste because it's all prefabricated. It's much quieter because no power tools, fewer deliveries, so 80% reduction in construction traffic, and really light. So the whole building weighs about 1/5 of an equivalent concrete frame building. So much reduced foundations as well. So that finished in 2008. And now every year we have this thing in London called Open House. And every year we have people, I do a talk here, outside there. And when it's sunny, we get lots of people. When it's raining, not so much. But a couple of years ago, when it was really nice weather, we had 600 people standing around here. And I was doing a talk. And the guy who lives here leant out of the balcony. He's got a parrot. The parrot sits on the edge of the balcony. And he leant out the balcony. And he was shouting things down at people, like, I never use my heating, and I can't hear my neighbours, and really helpful things like, it's all made of wood. So that's good.